Hello and welcome. I am Rajiv Gupta, a certified trainer and a senior technician at PCMacPlus.com. I am going to review the part 2 of hard drive interfaces, a subsection of A+ certification, domain 1, hardware section 1.2e. Let's discuss the SCSI and RAID. SCSI technology. As you can see in this picture, there is an adapter card and a cable is going from the adapter card onto the drives, and there are two external drives that are being daisy chained, one into another, and then another one into the card. So think about this type of configuration when you hear this lecture. SCSI technology. Other than ATA, another interface standards for drives and other devices is SCSI, which is primarily used in servers. SCSI standards can be used by many internal and external devices, including hard drives, CD-ROM drives, DVD drives, printers, and scanners. SCSI, pronounced SCSI, like SCUZZY, SCSI, stands for Small Computer System Interface and is a standard for communication between a subsystem of peripheral devices and the system bus. The SCSI bus can support up to 7 or 15 devices depending on the SCSI standard. SCSI devices tend to be faster, more expensive, and more difficult to install than similar ATA devices. Because they are more expensive and more difficult to install, they are mostly used in corporate settings and are seldom seen in the small office or used on home PC. If a motherboard does not have an embedded SCSI controller, the gateway from the SCSI bus to the system bus is the SCSI host adapter card, commonly called as host adapter. The host adapter is inserted into an expansion slot on the motherboard and is responsible for managing all devices on the SCSI bus. A host adapter can support both internal and external SCSI devices using one connector on the card for ribbon cable or round cable to connect to internal devices and an external port that supports external devices. All the devices and the host adapter form a single daisy chain. In the slide above, this daisy chain has two internal drives and two external drives. With the SCSI host adapter in the middle of chain, it fits into a PCI slot and provides two internal SCSI connectors and one external connector. Even though there are three connectors and all can be used at the same time, logically the host adapter manages all devices as a single SCSI chain and can support up to 15 devices. So here is the host adapter, and this connection is supporting the first device and the second device, which is a SCSI scanner. And inside of the case is one cable is going into SCSI hard drive and the SCSI hard drive, and then you are supposed to attach a terminator. All devices go through the host adapter to communicate with the CPU or directly with each other without involving the CPU. Each device on the bus is assigned a number from 0 to 15 called the SCSI ID. By means of dip switches, dials on the device, or software settings. The host adapter is assigned a SCSI ID 7, which has the highest priority over all other devices. The priority order is 7, 6, 5, 4, 3, 2, 1, 0, 15, 14, 13, 12, 11, 10, 9, and 8. Cables connect the devices physically in a daisy chain, sometimes called a straight chain. The devices can be either internal or external, and the host adapter can be at either end of the chain or somewhere in the middle. The SCSI ID identifies the physical device, which can have several logical devices embedded in it. For example, a CD-ROM jukebox, a CD-ROM changer with trays for multiple CDs, might have 7 trays. Each tray is considered a logical device and is assigned a logical unit number LUN to identify it, such as 1 through 7 or 0 through 6. The ID and LUN are written as 2 numbers separated by colon. For instance, if the SCSI ID is 5, the 4th tray in the jukebox is device 5:4. To reduce the amount of electrical noise or interference on a SCSI cable, each end of the SCSI chain has a terminating resistor. The terminating resistor can be a hardware device plugged into the last device on each end of the chain. The 3 major versions of SCSI are SCSI 1, SCSI 2, and SCSI 3, commonly known as regular SCSI, fast SCSI, and ultra SCSI. The latest SCSI standard, serial SCSI, also called Serial Attached SCSI, SAS, allows for more than 15 devices on a single SCSI chain, uses smaller, longer, round cables, and uses smaller hard drive form factors that can support larger capacity than earlier version of SCSI. SAS can be compatible with SATA drives, same system, and claims to be more reliable and better performing than SATA. Next, we are going to talk about RAID. How can we have hard drives working together with RAID? The need for RAID can be summarized in 2 points. The 2 keywords are redundant and array. An array of multiple disks accessed in parallel will give greater throughput than a single disk. Redundant data on the multiple disk provide fault tolerance, provided that RAID hardware and software perform true parallel access on multiple drives. There will be a performance improvement over a single disk. With a single hard disk, you cannot protect yourself against the cost of disk failure. The time required to obtain and install a replacement disk, reinstall the operating system, restore files from the backup tapes, and repeat all the data entry performed since the last backup was made. With multiple disks and suitable redundancy scheme, your system can stay up and running when a disk fails, and even while the replacement disk is being installed and is data restored. So you may ask, what is RAID? RAID is short for Redundant Array of Independent Disks, a category of disk that employ two or more drives in combination for fault tolerance and performance. RAID disk drives are used frequently on servers but aren't generally necessary for personal computers. RAID allow you to store same data redundantly in multiple places in a balanced A to improve overall performance. Two reasons you might consider using RAID are to improve fault tolerance, which is computer's ability to respond to a fault or catastrophe such as a hardware failure or power outage so that data is not lost. If data is important enough to justify the cost, you can protect the data by continuously writing 2 copies of it, each to different drive. This method is most often used on high-end, expensive file servers, but it is occasionally appropriate for single-user workstation. To improve performance by writing data to 2 or more hard drives so the single drive is not excessively used. Several levels of RAID exist, but the 3 most commonly used RAID are RAID 0, 1, and 5. What is disk mirroring or shadowing? It is a technique in which data is written to 2 duplicate disks simultaneously. This way, if one of the disks fails, the system can instantly switch to other disk without any loss of data or service. RAID 0 uses space from 2 or more physical disks to increase the disk space available for a single volume. RAID 0 writes to the physical disks evenly across all disks so that no one disk receives all the activity and therefore improves performance. Windows calls RAID 0 a striped volume, STRIPED. To understand that term, think of data striped or written across several hard drives. RAID 1 is a type of drive imaging. It duplicates data on one drive to another drive and used for fault tolerance. A drive image is a duplication of everything written to a hard drive. Each drive has its own volume, and the 2 volumes are called mirrors. If one drive fails, the other continues to operate and data is not lost. RAID 5 stripes data across 3 or more drives using parity checking so that if one drive fails, the other drive can recreate the data stored on the failed drive. Data is not duplicated, and therefore RAID 5 makes better use of volume capacity. RAID 5 drives increase performance and provide fault tolerance. Windows calls these drives RAID 5 volumes. This concludes the part 2 of hard drive interfaces. Thank you for watching A+ Certification 2009 review. Please recommend PC Mac Plus on YouTube to your colleagues and friends. Also, don't forget to post your comments. Thank you again.